Hi everyone, my name is Armend Azizi, and in this video I'm going to talk about Docker. Docker is the world's leading software container platform. It is a tool designed to make it easier to deploy and run applications using containers. So what is Docker and why do we need it? Well, if you're watching this video, the chances are high that you have heard or even used at least once the phrase, "it worked on my machine." To better illustrate this, imagine the following scenario where we have a developer with a Mac in one side who tested his program, it built, it worked, and he deployed it. On the other side, we have the tester with a different machine that is not a Mac, he runs the program and it fails. That can happen even when they have the same machine. The tester could have a Mac too, but with an older version of the OS or simply different configurations. So, what's the solution to this? One could go with a virtual machine, and this is what we commonly see in its architecture. We have the hardware, hypervisor, or guest operating systems and particular applications. Whereas in Docker, we have the hardware and host OS obviously, but now instead of a hypervisor and guest OSs, we have what is called the Docker engine. And on top of that, we have the Docker containers, which kinda do the same thing as the virtual machines. They can be run in different operating systems, allow developers to package up an application with all of the parts it needs, such as libraries and other dependencies, and ship it all out as one package. And most importantly, which is very appropriate at the time this video is being recorded, containers are isolated from each other, aka they are quarantined. Docker claims that these units provide the strongest isolation capabilities in the industry. So why is Docker better than VMs? There are a couple of reasons, but to mention some, Docker is more lightweight, occupies less memory, is much faster, containers have better performance since they are hosted on a single Docker engine, they are easier to scale up and easily portable across different platforms. So that's it for the long introduction. I hope that you have an idea what Docker is and why we need it. Now let's get into the real stuff and get our hands dirty, which again, I don't know whether it is the right expression to use, but you know what I mean. First things first, we need to get Docker into our machines. You simply search for Docker, click on the first link, and here is their main website. Click on Get Started and download the Docker desktop to allow Docker containers to run on our computers. I'm not gonna do that now since I already have Docker installed. After downloading and installing it, if we open a terminal and write Docker, we will get the list of commands with their respective descriptions. For example, Docker PS lists the running containers. With Docker images command, we see the images that we have pulled and so on. We will use some of these commands later on. To search for components, we need to go to the Docker repository, which is called the Docker Hub. We need to be logged in with an account in order to see the repositories. Here we can see some examples of components that come in Docker images, which are immutable files that contain the source code, libraries, dependencies, tools, and other files needed for an application to run. You can also search from the command line with the search command. You simply type Docker search and the name of the component you are interested, say Mongo for example, and you will get back the images with a name containing Mongo. Back to the repository. If you click on Mongo for example, we see how it is documented. On the right, we have the command to install that image. Here we can see the 1 billion plus downloads that it has. Then we have the basic stuff, the description, what Mongo is, how to run it, we are getting to that later, and how to connect MongoDB from another Docker component. We will look at this when we talk about component integration. And yeah, it contains many other guidelines, configuration, instructions, and so on. So let's actually install it. We copy this command, add it to the terminal, and with this we will get the latest tag, which means the latest version of Mongo that could be anything. If we want to specify what versions we want, we can add the tag like this, docker pull mongo 4.04, but we want the latest version, so we keep the previous command. The same command is also used when we want to get the updated version. And here we are. If we check now the Docker images, we will see Mongo listed there. Now we get the code to start a container. We go to the Docker Hub, copy the code, and paste it to our terminal. We delete the tag and we set a name to our container. We run it and check that the container is actually running and with our name. And yes, we see that that's true. Now let's start the Mongo program. Again, we go back to the website, copy the command to execute the program and paste it in our terminal. And here we can see Mongo up and running. To remove an image, we check the containers again. We see that Mongo is still running. So we need to stop that first, and if we want to remove it, since if we type docker ps-a, we see that the container is still there. So we need to use the remove command, which in Docker is rm. And we can see that it gets deleted. But we still have an image, which, as we can see, occupies some space. To delete that, the command is docker rmi, and we get rid of it for good. Now, how can we package a component for reuse and advertise so that it can be discovered? Well, let's create one and Dockerize it. What I will do is build the coolest website ever from scratch. Just sit back and watch me do it. And that's it. The coolest website ever is done. Now to run that, we need a web server. So I'm going to use Docker and use the nginx alpina server, which I pulled in the meanwhile. Then we need to create a Docker file that is just a text file with a list of steps to perform to create an image. In our Docker file, we add these two lines. The first one represents the image we are going to use, and the second one, we copy the contents of the current directory into the container. Next, we build the Docker image for the HTML server with the following command: docker build -t, the name of the user and the name of the image, followed by the tag, which is the version. I put v1 as a version 1. And run it with the docker run command, followed by the -d to run the container in a detached mode, and -p to forward the port 80 on the host to port 80 on the container. We can test this by checking the localhost 80 link. If we make changes to the code and reload the website, we see that nothing happens. We don't see the change since when we built the image, Docker made a copy of those files, and in order to see them, we need to rebuild the image. This is a big pain during development, and to solve that, we can use Docker volumes to mount a local directory for files as a volume inside the container, so that the container can look into the files that have changed. We need to first stop the previous container with docker stop and run a new container and add the option to mount a volume as follows. We add the full path where our files are to be mounted into the container in the directory that we specified in the Docker file. This one right here. Now, if we run that command, we can simply refresh and see the changes immediately. So far so good, but how do we deploy now this beautiful website so that it can be discovered and used by other people? Well, one command, actually two, plus the name. Docker push the name of our account and the name of the image. And that's it. If you go to Docker Hub repository now, we can see the coolest website sitting there, ready to be downloaded. Here we can manage the repository, change the description to the coolest website ever. And we can manage other stuff, like add the readme and other things. If we click on public view, we can see how it looks from other people. That's amazing. To add a new version of the application in the repository, I think you can already guess that it's very easy. We do our changes in the code, like for example add this paragraph here, then build the image with a new tag as a version. I will add version 3 since I added the version 2 before, and then do a simple Docker push. After it's finished, we can go to the Docker Hub now and we will see all the 3 versions. And we can download any one of them by specifying the tag when we do the pull. Last but not least, we are going to look at component integration. So far we have only seen simple examples of small number of containers working together. But what if we have a larger software system? How are the components integrated with each other? What if I were to make my application more complex and add MongoDB as a database, Redis for messaging, and Ansible for orchestration? We need to run all the images and link them with a link command to make the app work. These are all the commands we need to run one by one. A better way to do this is put them all in a Docker Compose, which is a tool for defining and running multi-container Docker applications. We configure it in a .yaml file, like this, by specifying the images and the connections. And to make the application run, we simply run docker compose up, and we are good to go. This obviously is more difficult in practice, but to go into the details, it's out of the scope of this demo. And that concludes everything I wanted to cover in this demo about Docker. I hope this gave you a better understanding about what Docker is and how to use it for deploying and running applications. Many famous organizations have their products containerized and available in the Docker repository Docker Hub, and many more are going to do so, since the future, as they say, will be Dockerized. Thank you very much for your time, and until the next one, goodbye.